In this video, I'm going to teach you how to solve the question on my screen. It says the characteristic equation for a certain feedback control system is given by the equation you see there. It says if the numerical values of A1 is equal to 22, A2 equal to 10, A3 is equal to 2, find K which corresponds to the stable system. Without wasting much time, let's start. I already substituted the values of A1, A2 and A3 in the equation, so we can start. Solution. The route array for the system given is s to power 4, s to power 3, s to power 2, S1, S0. Now, as usual, take the coefficient of s to power 4, 1, then skip the next coefficient and take the one after it. Skip the next one, take the one after it, which is K. The same thing here too, 2 and 0, as you can see. Now, to get the coefficient for the first column of s to power 2 is gotten by 22 times 10 minus 2 times 1 all divided by 22. This will give you 9.91. And then for the next one, it will be 22 times K minus 1 times 0 all over 22. This will give you K and then 0. Just follow me. I don't want this video to be too long. Just follow me. You can still listen to it again. Then for s to power 1, the first two, 9.91 times 2 minus 22 times K divided by 9.91, and you have 2 minus 22K over 9.91. And then for the second, it will be 9.91 times 0 minus 22 minus 22 times 0 divided by 9.91. That is obviously 0, and this will be 0 also. Then for this, this will be 2 times this value times k minus this value times 0, all divided by this value. And if you do that, you have k as your answer. This will be 0 and this will be 0. Now, the question says find the value, find k which corresponds to this stable system. That means find the value of k that will make the system stable. So now, in order to do that, we know that for stability, let me write this down. 2 minus 22k must be greater than 0 on this line. If it's not greater than 0, that means the system is not stable. On the other hand too, for stability, k must be greater than 0. If k is not greater than 0, the system is also not stable. According to the rule, the rule states that the first column of the Routh array, all values there must be positive. There must be no sign change. That's what it means. So using these two equations, we can get the range of values of k from this first equation here. Let's find k, where it ranges from. So from that equation, 2 minus 22k over 9.91 greater than 0. We can move, this will be 2 is greater than this, and then we can cross multiply. This will now be 9.91 22k. Then we can now divide both sides by 22. Meaning that this is greater than k. This is greater than k. And this value is actually 0.9. 0.9 is greater than k. Now and we also know that k is greater than 0, must be greater than 0. So we can now get the range of values of k. So the range, therefore, the range of the value of k is 0.9 greater than k and k greater than 0. So it means that the values for the system to be stable, k must be in between. That means k must be less than 0.9 and greater than 0. So this is the solution to this question. Don't forget to like and subscribe to this channel for more videos like this. Thank you for watching.